Hello, my name is Galushka Alexander. I'm taking Big Data Analytics from Harvard Extension School, and I would like to talk to you about Avro and Big Data today. I was working on this project and I would like to share the knowledge. What is Avro? Avro is a serialization system which has been invented, developed, and maintained by Apache. Well, it might be interesting what the serialization is. It's a process of objects and data structures generalization and translation to special readable format like XML, JSON, etc. So it can be stored on the disk and sent over the wire and be interpreted by a reader regardless of the system it's being read on. Avro is the next generation of serialization solutions. Avro's competitors are Parquet, Protobuffer, Thrift. Its built-in language serialization is one of the oldest ones. Language agnostic ones, such as JSON XML, which emerged in the late 90s, still being widely used. The binary serialization was the next step up, and Avro is taking the best of it, and it constitutes the hybrid serialization format type per se. So Avro provides a special file extension .avro, which is a JSON format header and binary content of the file, which adheres to the defined JSON header. We call it schema in Avro. Avro is very powerful for multiple things. One of their, I would say, marketable features of it is optimization techniques such as automated code generation. It also gives you a lot of speed up on MapReduce because the file has markers. Our file has markers that the MapReduce can use and split the data in chunks, and that would benefit it. Let me talk about the project itself. So what data I've chosen? I supposedly be choosing the data, big data set, greater than 10,000 records in it. The file is supposed to be greater than 5 megabytes. It should be unique. Well, in the sense of that no one in the class have been using it for demonstration purposes. This data has to be meaningful for data analysis. I was looking around and finally I settled on interesting statistics. I took this file from dataset file from San Diego area crime statistics. It is a span of from 2007 to 2013. This file is 100,000 records. It is about 20 megabytes. It has 26 columns in it. Before using the actual file, I had to clean it up a little bit. Let me explain what I actually meant by that. It is a comma separated file, so while you're going to be parsing it, you have to be relying on your comma separation. So you better make sure that in each column for each record there are no extra commas. So I use Excel spreadsheet to weed those out. I just basically search and replace for each comma there. Also, the data in ID column was completely missing, so I auto-populated it for all 100,000 records. Well, let's talk about the Avro schema. Let me show you how the actual schema look like. It is, as you can see, it's a JSON format. So for me, they say actually whenever you face with Avro, if you know JSON and understand JSON, you 70% understand Avro. So it uses JSON format. It has three main per se layers, four main layers: namespace, type, name, and fields. the name would represent the name of their class, the object that you generate. In my case, it's Java. The type of that object would be a record, and the namespace, the directory where this file will be living, is Harvard EDU crime stats. So you can see here there's multiple entries, ID, date, year. The types there are all primitives. Avro doesn't allow you to have objects for types, only primitives. And here's my data for from the data set. All the columns are laid out here. Now let's talk about the Avro code generation. There are two ways you can do it, and I'll show you in a second the actual POM file that I have here in Eclipse open. So you have to give it dependency, this guy right here, and you also have to define the execution, which is generate source, and then you have schema protocol, and you have to give it an input and output directory so it can take the schema and then produce the file for you. Also, you can use directly jar Avro tools and just compile schema with it. It will also produce this nice file. We go back to the code. I'll show you exactly how this file looks like. But this is it. It's very useful and come handy when you have, like me, 26 fields. So nothing special, but it's a nice touch. So it saves you a couple minutes of writing this class. It says auto-generated and do not add it directly. So parsing the data, I had a concern when I was thinking about the parser, how to implement it. And this is the reason I chosen the CSV file, because it's much easier to parse it. I had a concern that I'm going to be using returning the list of my crime stats, and the records 100,000 would be overwhelming for a Java list, but apparently not. It's no, there is no concern here. Maximum could be up to something billion records, so it's fine. Data serialization with Avro. Let me show you how it's actually done in the code. So I wrote this serializer Java class. Here it is. All you have to do is define your crime stats Avro, in my case, file that's going to be created. Then you have your datum writer, data file writer. Whenever the data set is parsed, I will have this data file writer crime stats object created with a schema from each record. So remember that each record, each crime stat has a schema, so you can return the schema back. You create that, and then you just continue appending for each record. And then whenever you close their data file writer, it will flash the file that you defined here, .avro1, right here, into the disk. Here we go, MapReduce with Avro. MapReduce with Avro is straightforward. It's very similar to other APIs for MapReduce in Java, at least. It has its own mapper, it has its own reducer, has its own run. Easy to pick up on. Again, I'm going to be switching back to the code. Here's my crime statistic analysis right here. So what I did is for my MapReduce job, I decided to do analysis on what's the most violent neighborhood, dangerous violent neighborhood in San Diego. And I took the most violent crimes, to my opinion, so robbery, sex crimes, and homicides. And whenever I run the mapper, I will only consider these guys here, and it will emit the name of the neighborhood and the number 1, basically. And the reducer will pick it up on it. What the reducer would do, it will take each record, and then it's gonna collect and sum it up. So and you run the job, and when you run it, here's my output. I can show you here. Let me grab this. Yep, so that's how what happens when you run it. Before actually running it, it's worthwhile looking at the configuration. So I created this BigDataAnalytics configuration, which takes two parameters: my Avro file as an input and the directory, and my output as an output. So if that's true, and if this job succeeded, I should get the folder here. Oh man, should the folder here and my output the success result, and then I have to look at this file and see what the results of this file are. To do that, I'll be using the command line, and here it is. The command for it is jar avro tools to JSON, and then you take this avro file. It will produce this nice formatted JSON text, and it's these numbers are popping out from the screen here. You can see that these guys, these neighborhoods, very bad. I'm on they stand out. I'm on the rest here, so it's NRM and RM. You have to look up the code, what that means. NRT. Well, there are quite a few safe ones, Sun, for instance. So that's my MapReduce job. That's what you do with Avro for MapReduce. Again, technology is interesting. It competes with other like protobuffer per K, Thrift, which haven't been covered in the scope of this presentation. But I will plan to look in those two in near future. Let me go through my slides again. So I covered that. MapReduce job output. And the project challenges I faced with, there were not much. The first one I mentioned before, that I had to find the easy to find, free, meaningful, ready to use big data set in CSV format. So quite a few constraints for my data set. I was managed to find one. So you can see I walk you through the process of data analysis for it. More successful. There were some hurdles with POM configuration. Well, documentation that Apache provides a lack of details and examples. So I spent a lot of time and hours pretty much on figuring out the syntax and what dependencies should be included, of how this execution works, and also the namespace that you define your schema is really confusing, because you have this namespace represents where the file goes, and if you run your command from the same place where your file is stored, and in my case right now I have the file stored in separate folders schema, so it will dig down in the directory starting from that root where you made a call, either from the command line or using the POM, and then it will put that file in. So initially I was getting this nested folders, and I was confused like why it's happening, and then I realized that actually it's a namespace that puts that file and creates a directory for you, the namespace defined in the schema again. So talking about Avro, just a few more comments. The Avro API is general for Java, Python, Ruby, C, C++, and other languages. Data stored using Avro can be easily passed from program written in one language to program written in another language. Let's say you can compile one in C, and then you can read it using a script language like Pig, for instance, or Hive. Thank you for watching my presentation. Appreciate your time. Thanks again. Hope you enjoyed it. Bye.